Welcome to Ask and Learn.
Let's find the critical numbers of the function g of theta equals 4 theta minus tangent of theta. Remember that critical numbers, or c is the critical number of a function, or let's say better this way. C in the domain of the function f is a critical number of f if the derivative of f at that number does not exist, or it exists and is equal to 0. So this is our definition of critical number of a function. That is, numbers in the domain of the function where the derivative does not exist or is equal to 0. So the first thing we're going to know about the function is the domain. And now we can say that the domain of g is equal to the domain of tangent of theta, because the only restriction in the formula of g is given by the restrictions on tangent of theta. And we know that is the real numbers minus, the real numbers minus all the multiples of 2 pi plus pi half and negative pi half. That is 2n pi multiple of 2 pi more or less pi half, where n the integer numbers. And that is because we know that the tangent of an angle is not defined for the angle equal to pi half or negative pi half, and then we have a period of 2 pi. That is why we get this formula here. So we have all the real numbers except those of this form. And it's there where we can find the critical points of g. Then we gotta find the derivative of g. We see that that's equal to 4 minus secant square of theta and that's the same as 4 minus 1 over cosine square of theta. And we can see here that the derivative of g does not exist for theta equal to where the cosine is 0. Well, cosine is 0 if we look at the graph here of cosine. We have 0 here. Pi half, cosine is 0, at 0 is 1. And we have here pi and 3 pi half and so on. Negative pi half over here. Negative pi and so on. So we see that it's 0 at pi half, then 3 pi half, so we can say that is at the point pi half plus multiples of 2 pi, because the periodicity of the function, the cosine of x, is 2 pi. So we get, if we know that pi half is 0, then we have all the other points from to the right and to the left, and negative pi half also. That is, we can say more or less pi half plus 2n pi. But as you can see, let's rewrite this a little bit more. Putting the multiple of 2 pi in front, so we get 2n pi more or less pi half. And as you can see, these are just the points that are not in the domain of the function. But these points, these values of theta, are not in the domain of G. That is, we cannot include these points of this form 2n pi plus more or less pi half. We cannot include in the list of critical numbers because these points, all these points, are not in the domain of G. And that's the first uh, requisite for the point to be a critical point, or the number to be a critical number. So the only critical numbers of these functions are those values of theta for which the derivative is 0. So let's solve the equation t derivative equals 0. That is 4 minus 1 over cosine square of theta equals 0. That is cosine square of theta equal 1/4. That is cosine of theta is more or less 1/2. That's the equation. So in fact, we have two equations. You have cosine of theta equal 1/2 and cosine of theta equal negative 1/2. If we look again at the cosine function, what we are looking for here is those values of the argument of cosine for which we have the value 1/2 and for which we have the value negative 1/2. And we know the cosine is an even function, so if we know one value, which is a solution, we know that the negative value also is a solution. In this case, for example, for 1/2, we know that this value here is a solution, and we know the cosine is 1/2 at the angle pi third. So negative pi third will also be a solution. So the two fundamental solutions for cosine of pi of theta equal 1/2 are more or less pi third. But then if we sum a multiple of 2 pi, we get the other solution. So this is that plus 2n pi for integer n. And for cosine of theta equal negative 1/2, we get the fundamental. Now we are looking here, negative 1/2 here. And so the first solution is, the positive solution is this one here. It's easy to see that the solution is 2 pi third, and then that plus 2n pi give us all the solutions of this equation, but we know that the negative 2 pi third is also a solution, so we get all these formulas here. So all those values of theta having this form here or this form here give us solutions to these equations and are those the critical numbers of the function g. So we can say that the critical numbers of g are theta equal more or less pi third plus 2n pi, or theta equal more or less 2 pi thirds plus 2n pi, or n any integer number. So these are the critical numbers of the given function g.